Okay. Okay, cool. No, thank you. Thank you. Cool. So just to brush on some of the key challenges that we've identified in this room over the past day or so, it's becoming a very difficult balancing act to account for the increasing regulatory and privacy demands and really just a complex regulatory and legal structure as a whole, with the understanding that every user has their own personal health journey and really that need and that want for a personalized experience. And this is really only made more complicated by the deprecation of the cookie, of which the dawn is finally upon us. And these are really all challenges that advanced AI is very well poised to solve. And so I think it was Emily who said yesterday that if you were to ask everyone in the room for the definition of AI, you'd probably have as many answers as there are people in the room. And I think the reason behind that is really that the term AI is an umbrella term. And so I'm going to give you my definition of it. It really is any type of smart machine. So AI is your standard calculator. AI is also Dolly. So there are many different forms of AI. And the specific subset that we'll be talking about today is deep learning. And so I know it's early, but I would just love to get a show of hands. Who in the room is familiar with the concept of deep learning? Okay, what if I said ChatGPT? Okay, that's what I thought. So deep learning is essentially the most advanced subset of AI. ChatGPT also exists within that subset. Facial recognition, self-driving cars, things of that nature. And really what differentiates this type of AI is that it has absolutely massive processing power. It can execute millions and millions of calculations in just a second. And so what that means is that it's able to very quickly identify very complex patterns and uses what it knows to make predictions about what it doesn't. And so it was no coincidence that Cognitiv was built in 2015 because that was the year of massive breakthroughs in this technology. And we were really built with the goal of enabling marketers to take advantage of advanced AI via custom algorithms and really to bring more intelligence to media buying and to media buying in particular. And so foundationally, there are 4 key pillars of our technology that very much separate our approach from the current paradigm. The first being that we train custom KPI and brand-specific deep learning algorithms that actually learn from your audience's content consumption habits and from their online behavior. We have a very advanced understanding of contextual. We actually do not utilize a keyword-based approach at Cognitiv. We pass every URL on the internet through the GPT-4 large language model to understand it like a human would. So not just necessarily the presence or the absence of a word on the page, but really how those words are being used. We have a range of proprietary data features that really facilitate a very granular understanding of who your audience is, utilizing what we call dynamic user profiles. So being able to understand how users' online behavior and how their interests are actually changing over time. And this is enriched by our proprietary identity graph, which is actually powered by LiveRamp and encompasses over 285 million US users. And so we don't just understand what users are doing online, but really how that's broken up across all of their devices, unique times of day, etc. And so the way that we're applying all of these pillars is via 2 key products, both of which are utilized by pharmaceutical marketers today, activating across display, online video, and CTV. The first being a custom, first-party specific and outcome-based algorithm. And what I mean by outcome-based is we take the site actions that you specify are important to your brand, and we're understanding the sequence of events and the key behavioral trends that are contributing to this outcome to essentially identify high-value users in the right mindset. And so what the algorithm is actually doing is assigning a conversion or outcome probability score to every single impression and either bidding in our DSP or sending high-value impressions to the DSP of your choice via Deal ID. And so the preferred seed data for this activation would be a pixel, but just understanding the nature of this room, we know that that's not always a feasible option. And so a year ago, we launched Context GPT. And it is what it sounds like. It's kind of like ChatGPT for context. And so as I mentioned, we don't actually use a keyword-based approach. And so just like ChatGPT with this tool, you can provide a very nuanced description of the type of content that you're looking to align with, or the type of audience that you want to reach, or even your media brief. And the tool will actually spit out the most relevant URLs in real time, just like ChatGPT. And so I've spoken a little bit about how we're using AI at a high level and what we're doing, and Jen's going to talk a little bit more about how we do this and look under the hood.
There you go.
Thanks.
Hi, everybody. As Danny mentioned, I'm Jen Novak. Talked to many of you. So great meeting so many people and learning from you. And I've heard a lot of questions about, what are we going to do when cookies go away? How are we going to first-party target or one-to-one target? And then also, everyone wants to use their first-party data. But I've also heard somebody had said that 56% of patients are doing all of this research before they actually go see the doctor. And that first-party data is largely being collected when someone goes to actually see the doctor. And then brands are telling me that that's that key moment, right? That's when we want to reach the patient before they actually go in to visit the doctor. And so what I'm going to talk about is actually how we enable and use deep learning AI to allow us to reach the consumer, the patient, before they actually go in to visit the doctor. So I'm going to start with, oh, I got to do this one. There we go. Oh, you can't hear me? Thank you. I'm going to start with how we do it contextually. So let's just talk about how we've been contextually targeting up to this point. We're looking at the URL. We're looking at title, text, images. Thank you. Title, text, images. And we're using keywords, or we're using even sometimes machine learning AI to bucket this website into a category, right, or a vertical. In this case, we're going to see this article, and it's about healthcare. But what we're missing is that this article is actually about allergy medication. Which one is best for you? Should you opt for an over-the-counter option, or should you go in and schedule an appointment and talk to a physician? So now using deep learning AI, which Danny mentioned, is a part of a technology that's used to create ChatGPT. We can understand the nuances of the text. But machines, they actually don't understand text at all. They understand numbers. So we see this and read this as actually a set of numbers. Each article we see is about 1,000 different numbers, and we call these numbers embeddings. And so just like ChatGPT, we use GPT model, like a large language model like GPT, there's others, to create a tool that we call Context GPT. And Context GPT is essentially, if you guys all raise your hands when we talked about ChatGPT, you go into ChatGPT, you put in a prompt, you get an answer. Context GPT allows for the option to put in a prompt. In this case, you're going to put in anything about an audience that you're looking to reach or content that you want to be relevant to or adjacent to with your ads. In this case, we're using a prompt for allergy sufferers. So we want to find content that is something that adults are looking up information on how they're going to manage their allergies. If you haven't noticed, I'm a little congested, so it's kind of relevant to me right now. Mucinex works really well for me. But so when we put in this prompt and we push that little pink button preview, what we get is a list of URLs. And in the bottom right-hand corner, you can see, I think you can see, right? It says unique URLs. So in this case, there's 14,000, and you can see the number of daily impressions. Now, what's great about large language models is that the more data you give it, the more it learns. So we've also included the option to add additional prompts. Or you can look at any one of these URLs, because again, we really feel that with any partner that you work with that says they do AI, one, they should be able to explain it, and they should be transparent and show you how they build those models. So we'll show you all the URLs. You can choose one. You can say, you know what, this is exactly what I want my ad to be next to. Click that little thumbs up, like button. It's going to read the page, and it's going to find more articles like that. And that's how we build scale against specific requests. But it's also important to understand that, ChatGPT really made this technology known for context, but it's not just applicable to context. It can also be applicable to how we understand online behaviors. So in this case, this consumer is researching vitamins and yoga on their phone, and on their desktop, they're looking up health, and they apparently need a massage. So in the current paradigm, how we've been behavioral targeting is we're looking at this one consumer on their mobile device and on their desktop separately. Unless you have a device graph, you can't connect the two devices in the full story of the sequences of someone's online behavior. But then we're bucketing them. And we're saying that this person is in market for fitness and might be a Whole Foods enthusiast, like the rest of us. But we're missing that whole sequence. And so deep learning allows us to connect the dots, not just between the devices, but what a consumer is truly doing online. So in this case, just like we did with context, we're going to assume and read all of the behaviors and assign different numerical embeddings, this machine representation, to a consumer's online behavior. And in this case, what this is telling us is that this person is actually, she was looking up vitamins for arthritis pain and joint relief. And she was looking up ways to, improve her diet so that she doesn't have inflammation. But we wouldn't know that in the traditional form of behavioral targeting. We only know that because of what deep learning allows us to understand. So when we see a certain set of behavior displayed, that's when we know we want to serve this customer, and we want to bid on an impression because she's displaying all of these attributes of pre-diagnosis for arthritis. So we've talked a lot about deep learning, but to summarize what Cognitiv does, we're solving the problems of privacy and personalization by allowing AI to really understand context at scale, identifying a holistic view of a person's online behaviors and personalization in real time, and then we're doing this all without being dependent on cookies. So if anybody has any questions or wants to talk through any use cases, please find Danny or I, but thank you so much.